Good afternoon, I am Mr. Ish. You are joining me for this fourth video on vectors. We're looking here primarily on resultant. A resultant is symbolized as such, a capital R, and it indeed is a vector. Resultants usually arise by vector addition. You have two vectors which added up and they gave you exactly the resultant that you are looking at. Each of these individual vectors u and v had something which had the basic elements u1, u2, and then you had of course the v elements v1 and v2. You added them up such that you were getting u1 plus v1. That's the first element of your resultant, and then here was u2 plus v2. When you were looking at all of this, you ended up getting an R1, and here you ended up getting an R2. Now R1, R2 are the individual elements of your resultant vector. Resultant is the item obtained or the quantity obtained from addition of two separate vectors. Now this one right here, you can easily determine its magnitude. You look at that same formula as you now know very well. You do R1 square plus R2 square, you'd add them up and you do their square root. You can easily determine the angle of the resultant with regards to a reference horizontal, and that would be determined by this tan theta is equal to R2 divided by R1, or your y divided by x, and you would take it through that formula. So here is everything you need to know about resultant. Now what we need to do is put this into practice so you can see it come into play. Our first question is this. We have to graph the vectors u, the vector v, and the vector r if knowing that vector u is made of 3 and a 0 and vector v is made up of a -2 and a 2. When you graph it out, it helps you a lot because you are able to visualize it. When you're looking at vector u, and you want to be accurate with what you're doing, because with vectors accuracy matters. Remember, the magnitude and the direction, all of that comes into play over here. When you're looking at vector u 3, 0, you're looking at a point which is right over here. When you're looking at vector v -2, 2, you're looking here at this point right over here. To determine the resultant over here, you can do this actually by the triangle or the parallelogram method. If you want, you got this everything here by the parallelogram method. When you do something here on an xy plane, you're looking at the parallelogram method. You would draw a good parallelogram and you would connect it here, and your resultant would be this. But you can mathematically show your resultant. Your resultant here would be just the addition of the two vectors. You will do u1 plus v1. When you do 3 plus -2, you get a 1. When you do 0 plus 2, you get a 2, and resultant is 1, 2. When you look right here, you have 1 and then comma 2, and there it is. Here's your resultant, here's your u vector, here's your v vector, and everything is shown to you as you can see it. Everything has been graphed, and very well everything could have been done by the triangle method too. U was right over here, you could have drawn u right over here, and then you could have transposed the v, because remember the triangle method, the v vector is added from the tip of the u vector, and it would come like in this direction, right? You would transpose this entire vector right over here. Then from the origination of your original vector to the end of your second vector would be your resultant, and this right here would very well mirror that. But anyhow, the question was to graph the u, the v, and the resultant and show exactly what the resultant is, and this is right here my resultant. Alright, that right there is my first question, and we've shown it to you by a variety of techniques. Now let's make our second question addition to this question. Alright, imagine now the second question is this. We have to find the magnitude of the r, and we have to find the angles involved. Alright, we have to find the angle of that theta. We might as well also look at the magnitude of u, the magnitude of v, and the angle of u and the angle of v. Now the u is actually very easy. Everything is here, 3 and a 0. The individual components squared and square root, you'll have the magnitude come very well as 3. And the angle here is very easy. It's on the x-axis. The angle here is 0 degrees. So that part is so easily done. The u vector components in terms of magnitude and direction are done. Now let's do the v. You're going to do -2 square plus 2 square and the square root. And you know when you do that, using the Pythagorean formula, you'll get 2 root 2. That's your magnitude of your v vector. And now look at the angle. We know all of that trigonometry. Let's put it to use. We can have inverse tan of -1. Remember, it's always arctan of your second component divided by your first component. We'll have a 135 degree angle come out. 2 divided by 2 minus inverse tan, you have a -45. But you can do -45 with respect to your 180 degrees, add it to 180, and you'll have 135 degrees. Or you can say here 3 pi over 4. Okay, those are your u and v vectors in terms of their magnitudes and directions. Now let's do the resultant. The resultant magnitude is not hard. You have these 1 and 2, you're going to put them in the formula r1 square plus r2 square, 1 plus 4, root of that is a root 5. Here's your magnitude of the resultant. Magnitude is a root 5. And what about the direction? Well, it's not too hard. You know it's going to be something in between 0 degrees and something in between 135. Somewhere it'll fall in between. But you don't have to do too much thinking over here. You already have the formula. You'll do arctan of your y component or your second component divided by your first component, which is 1. You're doing arctan of 2, inverse tan of 2, and you inverse it and you get 63.43 degrees. 63.43 degrees. So we are done. We know now our resultant is a 1, 2, our magnitude of u is a 3, the angle is 0 degrees. For the v vector, the magnitude is 2 root 2, the angle is 135 degrees. For the resultant vector, the magnitude is root 5, and the angle is 63.43, very well falling in between the 0 degrees and 135 degrees. So everything checks out and everything is good. And this right here is some of the resultant items that you need to know. Everything with regards to resultant I've presented to you over here. Thank you for watching. Have a nice day.